4.5, double angle identities. So you want to take a second to find your formula sheet and just find where these are. So what this means is the cos of twice an angle. So if I gave you an angle of 30, then the cos of 60, or 2 times 30, would equal cos squared of 30 minus sine squared of 30. It would also equal 1 minus 2 sine squared 30, or 2 cos squared 30 minus 1. Sine 2 times 30 would equal, or sine of 60 would also equal twice the sine of 30 times cos of 30. Tan of 60 would then be 2 tan 30 over 1 minus tan squared 30. So just some identities to work with there. Okay, types of questions you will see. We need to write cos 50 in terms of cos 25. So we need to say, well, which expression for cos contains only cos? So cos of 2 times something equals, well, this one only contains cos. This one has sines in it. So that's the identity we're going to use. So we say cos of 50 is equal to cos of 2 times 25. And the cos of 2 times 25 in the identity would be 2 cos squared 25 minus 1. Now we want to write cos 50 in terms of only sine. So looking back to those identities, cos of something in terms of only sine, we're going to use this one right here. So that would equal to cos, so we're going to rewrite it as cos 2 times 25, because that's 50, is equal to 1 minus 2 sine squared 25. So just manipulating those. Next it says write sine 50 in terms of both sine and cos of 25. So looking at those identities, sine of 50, we would say we're going to use this one. So sine of 2 times 25 is equal to 2 sine 25 cos 25. It says write tan in terms of tan 50 in terms of tan 25. Using those identities, we can say that's tan 2 times 25 equals 2 tan 25 over 1 minus tan squared of 25. So you'll see I just also got that from tangent right here. Okay. Of course, they're not going to be that easy. So if tan of x is 2, and x lies between pi and 3 pi over 2, so this is pi, and this would be 3 pi over 2, so x is this angle here. Find the exact value of tan of 2x. Okay, using identities, I know that the tan of 2x is equal to 2 times tan x over 1 minus tan squared x. The piece of information I know is tan x is simply 2. So I have 2 times 2, because that's tan x, over 1 minus 2 all squared. Okay, this simplifies to 4 over 1 minus 4. So 1 minus 4 is negative 3. So negative 4/3. Whenever we do this, though, we have to look at, at this analysis. Okay, so we said x is between 3 pi over 2 and pi. I just got that from right there. But now we've doubled x. So we've also doubled this, and we've doubled that. So in other words, it's between 2 pi, and this would be 3 pi. So what does that look like? Sorry, that should have been 3 pi over 2 from the beginning. So it's between 2 pi is right here, 3 pi is here. So the tangent here, why can't I do this right? Sorry. So I'm saying it's between 2 pi and 3 pi. That's how big the angle is. Well, tangent could be negative, like it is, if it was here. It also could be positive. So we're just going to keep this answer because that's reasonable. Okay? Sine of 2x. Well, sine of 2x, according to our identities, the sine of twice an angle is equal to 2 sine the angle cos the angle, and you're saying that doesn't help us. Don't worry. We'll get there. Okay. So we have this is equal to, using the identities, 2 sine x cos x. We don't know sine x and we don't know cos x, so we need to find these. All we know is tan x. So the first identity that I'm going to try and use is I'm going to use an identity that relates secant to tan x. I'm going to use secant squared x is equal to 1 plus tan squared x. So secant squared x is equal to 1 plus 2 squared. So I get secant squared x is equal to 5. So that must mean that secant is equal to the square root of 5. Secant x is equal to the square root of 5. Wait a second, we got to look back here. But we said that x is over here. So tangent's positive, but secant would be negative. So if that's what secant equals, then I can tell you what cos equals. Cos x must be negative 1 over root 5. And if we rationalize that denominator, times by root 5 over root 5, we get negative root 5 over 5. Okay, so I have cos x. Now I need sine x. How do I get sine x if I have cos x? I'm going to say sine x squared plus cos x squared equals 1. Okay, I'm just going to do it all over here. So sine squared x plus cos squared x is equal to 1. I'm trying to figure out sine. Well, cos squared x is just root 5 over negative root 5 over 5 all squared. Run on the one space. So this is equal to 1 over 1 minus 5/25. Wait a second. Did I do that wrong? Just a sec. No, I didn't do it wrong. In my notes I had 1/5. Well, 5 over 25 is of course 1/5. So 1 minus 1/5 is 4/5. We need to square root that because this is sine x squared, so we're square rooting both sides. So this is equal to 2 over root 5. We are going to rationalize that denominator, so we're going to get 2 root 5 over 5. Look at the quadrant that x is in. X is still in this quadrant right here, so that is going to be a negative there. So we have an answer for, woo, somebody threw something at the, or a bird. I just got scared. Okay, at the window, sine x is equal to negative, and there is cos x. Okay, so now we can sub this in. This is equal to 2. Sine x is negative 2 root 5 over 5 is what we found. And cos x we found to be negative, it's down over here, negative root 5 over 5. We're going to simplify. Okay, so we get 2 times negative 2 is negative 4. Root 5, oh, there's another negative sign, so that becomes positive. Root 5 times root 5 is just 5. 5 times 5 is 25. So this is equal to 20 over 25, which is 4/5. Okay. Next question. That was a doozy. Derive an expression for sine of 3x in terms of sine x and cos x. So we're going to rewrite this as sine 2x plus x. Now we're going to use some prior knowledge. Sine of 2x plus x is equal to, this was yesterday when we had a sum. This is equal to sine of 2x cos x. So this is those addition identities. You should grab those out. Plus sine x cos 2x. So remember we said we adding two things and then we use this identity. But we know, we just learned what sine of 2x and what cos of 2x is equal to as well. So this is equivalent to 2 sine x cos x times cos x. So this was simplified to be that. Plus sine x and cos of 2x is cos squared x minus sine squared x. Okay, let's see if we can simplify that. This should be 2 sine cos squared x, and this is going to be sine x times cos squared x minus sine squared x. And you know what? We could keep going and simplifying that as well if we wanted to, but it wasn't really, they didn't really tell me where they wanted me to go. I could factor out a sine x maybe. I'm going to move over here. I'd be left with 2 cos squared x plus cos squared x minus sine squared x. I could simplify that to be sine x 3 cos squared x minus sine x. It's probably about as simple as I could get it, depending on what you wanted to massage that to. Okay, so a new set of identities, but still remembering the identities from last day.